For example circuit number 10, we're going to look at another motion-based element, in this case a motor. However, in order to power our little DC motor, we're going to need more current than the Arduino can provide in order to control it. So we're also going to include a transistor to switch that high current application using our low power control circuits, or our low power control output from the Arduino. So if we head over to the schematic we're going to be using for this particular sketch and circuit, you'll see that we've got some new, or a new item on the thing. This is our transistor, and it's going to essentially be acting as a switch for our motor. When we send power to the transistor, it's going to allow current through, so the motor will spin. Otherwise, it'll act as an open circuit and the motor won't. So in order to wire this up, we're going to take our 5-volt control, or our 5 volts, from our Arduino, and we're going to wire it into the plus side of the motor. And we're also going to wire that plus side into this diode we've got here, except first, we're also going to wire it into this diode, except first we're going to need to flip that diode around and move it into a slightly better position. Okay, so we're going to wire the plus side of our motor into the minus side of this particular diode, and we're going to wire this diode across our motor. And this is acting as what's known as a flyback diode. Now, the motor contains an inductive element, which is a coil of wire. And whenever we start sending or stop sending power to a coil suddenly, it will discharge a spike of voltage across the opposite direction that it was normally receiving. And for some cases this will be fine and won't hurt anything. Specifically for our transistor, if we allowed that spike of voltage to hit our transistor, it could potentially damage it. So our flyback diode is wired in so that when we stop powering the motor, it doesn't spike voltage into our transistor and burn it out. So we wire the collector pin of our transistor into the output from our motor and to the positive side of our flyback diode. Then we connect the emitter pin over to ground. And finally we hook our control pin through this resistor over from output pin number 9 on our Arduino. So the transistor is acting as a switch. When we send our signal from the Arduino, the transistor will allow a certain amount of current through, which will let the motor spin. And the flyback diode here will prevent our motors de-energizing from burning out our transistor. So if we head over to the sketch that we're using to control this particular motor, we've got the sketch, and comments include, once again, a bunch of detail about how we're using a transistor and a motor and the purpose of the flyback diode. So the sketch starts by defining our motor pin as number 9, and setting up our motor pin for output, and also setting up a serial window, because one of the things this program is going to do is allow you to set the motor speed using serial control. Now, the program essentially calls a few different functions, and those functions will tell the motor how to behave. So the first function is motor on and then off. So when this function is called, the motor is going to turn on for some time and then turn off for some time. So int on time 3000, int off time 3000 for calling motor on then off. So we're going to write to our motor control pin which will essentially open up our transistor for control. So turn on the transistor, wait, turn off the transistor, wait. So that's going to turn on and then off. So let's actually go over to our circuit, and we've got motor right here, and the transistor is this guy right here, and our flyback diode, though nearly invisible, is wired in over here. So this is our flyback diode. So we've got our motor, and I put this little piece of tape on it so you can actually see it spin. So if we head back over to our sketch, and we got it on then off, and we upload this sketch, motor starts spinning, it'll spin for 3 seconds, stop, spin for 3 seconds, stop, and it's spinning at the maximum speed that it's capable of receiving. So I'm going to head over to a blank sketch. That's a serial window. File, new. I'm going to upload a blank sketch so that the motor stops spinning and I stop needing to hold it in place. We head back to this one. So that's just turning the motor on and off. The next function is motor on-off with speed control. So we head down to the motor on-off with speed function, and first they define int speed 200, where 0 is stopped and 255 is at full bore all open, and a time 1, so 3,000 milliseconds or 3 seconds, and speed 2 at 50, and time 2 at 3,000 milliseconds. So we're going to write to our motor pin speed 1. So we're going to send it, instead of just sending it 5 volts full bore, we're going to send it 200. So we're going to send it partially on. And it's going to do that same pulse wave modulation that it did with the LEDs earlier. It's going to blink on and off for some period of time that averages out to that 200. And then we're going to wait 3 seconds. Then we're going to go to that lower speed and wait for 3 seconds. Now this lower speed might not be high enough to actually get the motor spinning. It might not be enough power, so it might turn off, or it might spin at that other low speed for some period of time. Now, we've got it over to motor on-off with speed control. We're going to switch back over here to where we can see it, and we are going to upload this sketch. The motor starts spinning, goes down to a lower speed, goes up to a higher speed, goes down to a low speed, goes up to a high speed, and you can mostly hear the difference in the speed, and you can even see it just a little bit. So I'm going to upload my blank sketch again so I don't need to keep holding my motor. And we go back up to the sketch. The next function they give you is motor acceleration. So we go down to the motor acceleration function, and they say int speed, so they define a speed variable, and then they define a delay time of 20 milliseconds. So they start with a for loop where speed starts at 0 and goes up to full bore 255, increasing by 1 each time. Analog write motor pin speed. So send to my motor pin the value of speed and then wait the delay time 20 milliseconds. And then they also write in another for loop for speed starting at 255 and goes back down to 0, completely off, speed minus minus, so go down by 1 each time. Write that new speed to our motor, or specifically to our transistor to control how much current it's allowing through, and once again wait the delay time. So this should have it speed up to full bore from nothing, and then once it's hit full bore, it should slowly ratchet back down to off. So this should be a smooth increase from off to full speed, and then from full speed back to off. So we make sure that we're actually calling the correct one, motor acceleration, and then we switch over to our motor, and we upload the sketch. And it speeds up to full speed, and then slows back down, and then speeds up. So there's actually some values towards 0 which aren't quite enough to actually get it spinning, and so it sort of whines as it receives power, but isn't actually fast enough or enough power to get it spinning. And so you'll have to find out what those values are for yourself with your transistor and your motor. But as you can see, it speeds up and then slows back down. And so uploading our blank sketch again so I don't have to keep holding it. And then finally back to the sketch for one last function that they've included. And the function they've included as the final one is serial speed. So if we go down to void serial speed, we have int speed. So create a variable and call it speed, and it'll hold an integer. And then in our serial window, so serial window over here, first print type of speed from 0 to 255 into the box above. So up here is where I can send serial commands over to my thing. And then on the print line, then click send or press return, and then print on the next one. Just print a blank line so that there's some space between this header and what we're about to do next. And then while true, and so this loop is going to loop forever, because while true will always be true. So once you've called this function, you can't leave. And while serial is available is greater than 0. So this is checking whether or not it can receive a serial input right now. And if it can receive a serial input, then it's going to say speed equals serial.parseInt. So it's going to go into my serial, see if I've given it a number that it recognizes, and if it does, it's going to put that into speed. But because analog write only works with numbers from 0 to 255, they're going to constrain that input to somewhere between 0 and 255. Then they'll print a message to let you know that the number received, setting speed to space, and then it's going to print that speed, and then it's going to send that speed to our motor. Now, when I was doing testing for this one, I found that if you don't input anything, it's going to take that as a value of 0. So if I give it a speed, it's going to run up to that speed, and it's going to run for a second or two, and then because serial is available, it's going to take my inputting nothing as 0 and stop the motor. So if we upload this now, the motor won't start spinning because there should be no inputs, no controls. So it says type of speed, and if I'm holding the motor and I say 200 and hit enter, you should be able to hear the motor spin up and then spin. And as you can see, it took no further inputs as a 0 and set the speed back to 0. So if we wanted the motor to spin for longer, we could include a delay command here. So let's say 3000. So I want you to wait at least 3 seconds after receiving your previous command before you go back to checking if there's serial available again. So we can upload this modified version here and type a speed, and I'll type in 100 this time. And the motor spins for at least 3 seconds, and then it takes my non-input and interprets that as 0 and turns the motor back off again. So if I wanted to keep doing this, or if I wanted to hold a certain value, I'd have to adjust this delay, or I'd have to sit here continuously typing, I want it to be 100, yes, I still want it to be 100, yes, I still want it to be 100, yes, I still want it to be 100. So I'm going to move this out of the way so that I can actually see it when I've got this up. And so when I type in 100 and hit enter, it spins up, waits 3 seconds, and then takes my non-input as 0. Now if I type in 100 and I type in 50 after that, it slows down to 50, holds for 3 seconds, and then takes my non-input as 0. So that's how you can control something using a serial input. Your serial window is good for more than just printing out various states that your program's in so that you can monitor it. You can also take serial input from this window and use it to control something like your motor.